Hello everybody! In this tutorial I'm going to explain to you the different types of memory that you have in C++. The two different types of memory that you have are called the heap and the call stack, commonly referred to as the stack. The difference between the heap and the call stack are that the heap is bigger but slower and the call stack is smaller but faster. Basically the call stack is the memory that you use whenever you declare variables the normal way, so like you've been doing thus far. But sometimes you need variables that are bigger or contain more data than you can store on the stack, and that's where the heap is for. The heap is basically a memory pool that's normally not accessed. You need to specially access it using something called pointers, which I'm going to explain to you in the next episode. One big note when it comes to variables on the stack and the heap. Variables on the stack get destroyed whenever the program ends, but variables on the heap don't. Variables on the heap need to be manually destroyed. So let's now go to a visual example. So here in a visual example, the black row represents our memory on the stack, and the gray row represents our memory on the heap. Up here we have our different variables. The variable yellow, which might represent for instance a string, contains 5 memory blocks, red 6, which might be a class, and then we might have an integer, and then another float with the size of 4 memory blocks, and then maybe another class with the size of 8 memory blocks. So if you allocate all the memory on the stack, then you will see that if we allocate all of them, we will run out of memory, since I'm still missing 1 memory block for the 8. And this happens quite a lot on the stack. And the error that you then get is called a stack overflow. That means that you've used all of the memory on the stack. But how can we solve this problem? What if we need more memory in order to make a program run and our computers are fast enough and have enough storage in order to actually give us all the memory that we need? What we do then is we use the heap. So we store our variables on the heap. So let's first make all of the allocation undone on the stack. And let's now allocate our memory on the heap. What you can see now is that we actually haven't run out of memory. We could store all of the data without any problems. But right now we wouldn't be able to access the variables in our program, since our program can only access things from the stack. So what we need in order to access something from the heap in our program is a pointer. What a pointer basically is a memory address. So it contains the beginning of the memory. So in this case, if we allocate a pointer for yellow, then it will point to the first memory block, since that is the beginning of the data for yellow. And then if we allocate a pointer for red, it will point to the 6th memory block, since that's the beginning of red, and so on and so on. So as you can see, we saved a lot of memory just by allocating things on the heap, and using pointers in the call stack. We saved up a whole lot of memory that we can now use for other variables. There's only one problem though. It's not a big problem, actually like a tiny problem. But pointers are always slower, since you're pointing to memory that's basically not normally accessible by the program. It needs to specifically ask for the memory. Let's for instance say you're at a bookstore. You can either pick one of the books that's already there, and you will get it really quickly, or you can go to one of the computers and order one of the books that you really want, but it's going to be slower, but it can be whatever you want. It's the same with the heap and the stack. The stack is basically the store. You can get whatever is there, but the size is limited. You only can choose out of a limited amount of books. But the heap is everything what you want. You can store whatever you want there. You can buy whatever you want there, but it will take longer for you to get the book. But this is not always something that you should worry about. Let's for instance say you have a variable amount of enemies. You don't know how many can be, but it can be more than what a stack can handle. And it's better to allocate all of the different enemies on the heap, even though you might be able to store them on the stack. So it's kind of this balancing act of quantity over speed. That was basically all I had to say for today. So thanks for watching, and I'll see you in the next one.